Welcome friends. Today I am going to demonstrate the different methods of GPS surveying. Now to start with, as I already told that in GPS surveying there are different methods like single point positioning, relative positioning, and under relative positioning there are different ways we can do it, like static surveying, kinematic surveying, and again kinematic surveying there may be stop and go and kinematic. Again in under real time we can go for RTK method. So I am going to demonstrate you on field the different methods of GPS surveying. To start with, let us do the point positioning. So at the time of point positioning, first we have to identify a station on which we have to set up our instrument, and that is generally known as reference station. So this one is our reference station. Here we have kept a pointed, so that is the for centering purpose. So after identifying the station, we have to keep our tripod stand. So this is the tripod stand which we like to set up on this. So before setting up, we have to first open it and take it out to as much height as possible, convenient to your height. So now we are fixing it after raising it. Now we have to take it, spread around it in such a way that all these three legs should be spread well, equally spread, and this should look through this part to make the approximate centering, as well as we have to make the leveling approximate. So approximate centering and approximate leveling has to be done spreading the legs of this tripod stand. After that, we have to take the tri-back. This is the tri-back, along with this is the tri-back, and this is the antenna adapter. Both are put together, and before we are placing it on the head of the tripod stand, we have to take these foot screws in the middle between the tri-back and tri-back, so that approximate leveling is to be done, and that you can see through this bubble. There is a bubble where you can see about the leveling part. Now we will fix it. So this is the optical plummet of the instrument through which we look through to see whether our centering is just on this tip or not. Now by adjusting this tripod leg, we have to make it level. Leveling we will be able to understand by seeing the bubble at the bubble tube. It should be at the center of this bubble tube. So now it is level. Now we have to check whether centering has been done. Now this part has been centered properly as well as level. This is a very important operation to reduce the amount of grass error, as I had discussed in errors in GPS observation class. Now we will fix the antenna. This is a very high ended antenna called geodetic Jeffrey antenna, which removes the multipath errors. So now we are fixing it. So taking the adapter here, placing it. So this is how we have placed the antenna. Now we will connect our antenna with the GPS receiver. Now this antenna will be connected using this connector to this receiver. So in this receiver there is a symbol where it will be easily understood where you have to make it. So there is a symbol of GPS. So because this antenna will receive the GPS signal. So we will be, so now it is connected. Next we will connect with this receiver the controller. So already I had shown in the class, this is the controller which we will be using here. So one end of the controller will be placed here and the other end will be kept here. So after this we have to, so the battery is already within this part as well as this part, so we do not need any external battery for our work. Now we can start. So one thing we should note that after connection is over, we should be as far away as possible from the antenna, because otherwise the signal will come GPS from our head also, it can go to here, which may cause multipath. Now you can see our arrangement, we have open sky, and you can see if we take an approximately 10 degree or 15 degree, so there will not be any obstruction, physical obstruction. So that is very important. So we have taken our reference station on the top of the roof. After the receiver has been set up, that means antenna has been centered and level on the point or reference station and the proper connection with the receiver as well as controller. First we have to make this controller open, so that after opening we get this screen. Now from the start menu we can go inside and we can see the Trimble Access is the field software which is to be used for our surveying work. So this is to be opened. Now it is opening. So this is the first menu. So now we have to open the general survey. So here you can see here the 95% is the amount of battery charges that is available here. Then the then another 91% is from the receiver. So anyway, so now here you can see the satellite, there are 8 satellites we get connected, and the our controller is properly connected with the receiver. So it is giving an antenna is also properly installed. So now we have to go for jobs. We have to create a new job. So we have to give a name. Let us say the job name is job 1, first job 1, and keeping all other parameters okay. Now we will not be changing any other parameters. So we can also COGO settings, we can do it here. The if we want we can change some of the, like sea level, we want to get the height with respect to sea level, then we can tick it, accept. So we have accepted, that means job has been created. Now we have to start measurement. Now if we click, we can go inside the measure, but before that we can also check. You can see here PDOP is 2.1. So in our lecture class already I told you, if the PDOP is less means we have a very good geometrical constellation of satellites. So we can start our work. Now let me click to fast static. As I told you that the fast static is another version of static surveying. So when the duration is less, then it is fast static, because we are going to take a small duration observation. So we have started with fast static. Now start base receiver, since this is the reference station and also it is called base receiver. So we are starting the base receiver, and we can give a name to this point. Let us say this is the point, our reference point. So, roof top reference. So, this is the name given to it. So, now we had to measure the antenna height. Now antenna height can be measured. This is the way how we do take. This is called slant height, and the height is how much? 1.09. 1.09. I am to feed it and measure to bottom of notch. So now I can start taking observation. So starting survey, this the base started, okay. So now the measurements are being taken by the through the antenna to the receiver, and the observations are being recorded inside the receiver. Now we can exit out of it. Now it will be continuing to take. In the meantime, we can go for next method. Now we will be demonstrating the real time kinematic surveying. So after setting up the reference station, we have to set up another station called communication setup. So here also we will first take a tripod stand, where we will take on the antenna setup, we will take a radio communication antenna. So this is the communication antenna. Which has to be connected to a stand, so that the antenna height gets high enough, so that the communication can go far off. So this is an arrangement so that no bird get strikes on it. So this is the communication antenna, which will be used for communicating the radio message from reference to rover. Now we will connect this antenna with this is the radio arrangement. So this is the connection, we have done it, and another connection we had given to the battery power. Now we are connecting it power. This is all about radio communication. Now we have to make it on, and before make it on, we have to connect with the receiver. This is the receiver. After getting our receiver and the communication antenna installed, we have to go for our field software to be operated to communicate from reference station to rover station. So start with a job. So usually we go for a job which is already opened, and where the data for the reference receiver is already there. That means we need to take a station whose location is known. So this is a job we are taking. So now we will start measurement. So under the measure there are different types. We are to going for RTK. So clocking. So first we have to start base receiver. So clicking base receiver we are getting. Now under point name we have to take a name which already we have taken the data, that means known point. So base, so we have taken and we can start now. So, now you can see that base has been started. Okay. Now, the reference receiver from reference or base receiver, this radio communication is communicated through that radio communication systems. So, now we have to go for this radio communication to reference rover station. After the fixing and communication unit of the reference station has been set up, now we will go for setting up of the rover station. First we will, this is a rover antenna which is also a Zephyr antenna, which will be fixed with a vertical stand having two legs, that is called dipod legs. Now this will be placed in a vertical condition using these dipods, so that the here we have the bubble which gives us the impression about the level. So after it is fairly level, we will fix up the receiver with the stand, and then this there will be connection between the antenna and the receiver. Then also we have to fix, this is the antenna, receiving antenna to be connected to the receiver, that is called rover antenna, and then we have to connect the controller. So with this our connection is over. Now you can see here that green light is blinking, means this rover receiver is receiving the radio communication from the reference station. Now we can start measurement of this point location in real time. So let me go to the RTK, measure point, starting survey RTK. Now index 29, reliability 100%. So if you remember, this is the index of the reference station, we have so 100% reliability. So accept, starting survey. So we have given this rover 6 name, so measure. So as we have given the name measurement, it is measuring. Now you can see here RTK fixed, all this is given, so I can store it. So observation has been stored in RTK mode. Now we can take this rover to some other station, and again we can do the same operation to measure the point on RTK mode. With this we can conclude the RTK survey. Now after our reference station has been set up at the reference location, or base station has been set up as the reference station, now we will be setting up the rover station for our relative static positioning. So this is the point whose location we need to find out. So we have to centered as well as leveled our tripod stand on this point. So similar to what we did in the in case of reference station, we are doing the same thing. First we are opening the tripod stand and we are raising it the height, and then we are taking the tripod stand around it, so that the tripod stand is centered over it as well as more leveled. Then we will be taking out the tripod head, tri-back head along with the antenna adapter. So after taking these 4 screws in the middle, we have placed it here, and now we will make it leveled and centered. This is the optical plummet through which we see about the centering, and this is the cross bubble which provides us the level part. So, now this tripod stand has been centered as well as leveled. Now, we will be fixing up the Zephyr antenna and we are placing it on the tie bag. So, after the antenna has been placed on a centered and level tripod stand, now we will be connecting the antenna with the rover receiver. So, again on that port where GPS has been written, and with this rover now we have to connect the controller. We are placing the receiver in the tripod stand itself. So, now we are connecting the controller wire with the receiver. Now, after getting the wires connected as required, now we will start. Now, after making the controller on, this is the starting menu. From the start icon, we are getting this starting menu. So, Trimble Access is the fields software. So, we are opening it. So, it is open. Now, we go to the general survey. So, from the job, we are opening a new job. So, say it is job 2, enter, accept. So, now we have to measure. So, because it is a relative static method, so we are taking the static as our option. Now, we have to measure point. So, we can give a name to this point. Suppose it is rover 0 1 and method. So, antenna height, again we have to measure the height of the antenna using the appropriate measuring stick. Since we want to measure the height of the height of the field, so
1 point.
so it is 1.14.
1.14.
So we are getting it
44.
1 point
1.40 कर दिए.
okay ठीक है ठीक 1.40. So enter. It will be antenna phase center करेंगे.
हाँ नहीं माउस करेंगे. हाँ इसे 10 सेट आएगा. 10 सेट.
So measure. So it has started measuring.
टाइमिंग स्टार्ट.
हाँ
इसे टाइमिंग चल रहा है ना सर.
हाँ
अपना ये टाइमिंग चल रहा है.
yes yes.
स्टोर आएगा.
So this is the time to go. That means minimum 8 minutes we have to take. We may increase also. If we increase, if we go on taking, it will take. So that is what we have to do it. Now in the meantime, if we can see that the PDOP is 2.3 and the height of the antenna is 1.400, what we have entered, that has been given correctly. There are 6 satellites and these are the 6 satellites which can be seen now. So in this way we can list also these satellites, their angle of elevation then other parameters. So, once the observation is over, then we can stop by giving abandoned points, yes. So, we are about to complete our observation of, so we are now completing it. So, only 14 seconds, now 12 seconds, 11 seconds.
Observation stored.
So, you see once it is observation is over, again it is tailing measure, that means we can go to next point and we can take our next observation. Now, I will demonstrate you the relative method of surveying, which is of stop and go type, in which we have already set up the reference receiver in the reference station, and now we will be setting up our rover station. Before taking the measurement in this method, first we have to go for initialization. Now, here you see that we have done the we have placed the antenna on a point after properly leveled and centered, and this is a temporary point where we will be initializing we will do the initialization process. Now, in order to do, after doing the necessary connection as did in case of rover receiver in relative positioning, we did the same thing, only we had done it in a different station point, and now we have to do the initialization process. For that, after the opening the field software Trimble Access general survey, we go again, we should go for a new job. Suppose we are giving the name as job, stop and go, enter, accept. Okay. Now, next after opening we should go for measurement, it is the PPK. So, measure points. So, it has started the post processing kinematic positioning. So, let us say the name as rover 6 and the antenna height we have measured as 2 meter. So, we kept it. So, enter, measure. So, after opening the job, we want to go to, we are now starting measurement. So, before starting the measurement, we should go for initialization. So, we are doing the initialization process in it. So, new point, we are taking a new point, start. So, here and the antenna height, so it will require 15 minutes time to initialize the process. So, you can see 7 minutes time. So, initialization has been stored. So, now can start measurement of point by stop and go method. Now, we are starting measurement of some salient points. As a demonstration, we have taken some points marked on this floor whose point position we will be determining by using stop and go method. First, after initialization, we have stopped measurement and we have brought the receiver to a stand and kept on the point on which for which we want to find out the position. Now, I will take to the measure and measure points. So, now if as I take the measure point, so now it has started to measurement. So, as the measurement is over, it has come the store. So, now I can store it. So, when it is stored, then the name of next point rover 8 has come automatically, which we can measure, that we will do after shifting our instrument to next point. So, let us go to the next point. So, after keeping the stand just at the center of the point and making it a bit level, through this bubble we can get the leveling. Now, I am starting measurement of the next point. So, the measurement is over, now I can store it. Now, one thing we should keep it in mind, that during measurement we should keep hold without making any movement. Anyway, so now the name has been changed automatically to rover 9, which will be the name of the next point. So, this is the third point which we want to measure, whose name is rover 9. So, as we have centered it, leveled it, now I will start measurement. So, now we can store it. So, we can go to the next point. Let us go to the next point. So, it is the rover 10. After leveling and centering, we have started measurement. Now, store. So, in this way we can go on continuing our measurement and define points, salient points, and we can further during post processing we can get the position. So, with this I want to conclude about our demonstration of stop and go method. So, already we know how to carry out the kinematic GPS surveying. First, what we did, we have set up our reference station or base receiver to the reference station. Then we had taken the rover receiver to some initialization point and we completed our initialization, and after the initialization now we will do the actual measurement of the kinematic positioning. To start with kinematic surveying with the rover survey, first we have to create a new job. So, new job. After creating the job, we have to do our initialization, which is being done now. Once as the initialization process is been over, now I will measure the along this line marked in the floor. So, as a matter of demonstration, so we have to tick continuous topo, then I am ticking to start. Now we are movement, you walk along this line as slowly as possible. The slower the movement, more will be accurate. चलो चलता चलो ना वो अपने आप करें. So with this I want to end today's demonstration on kinematic movement. So that's the completion of our demonstration. In this demonstration I had shown you the point positioning, then relative positioning by static method, and then in relative positioning also I have demonstrated the stop and go method, kinematic method, and also finally I had shown you the real time kinematic method. With this I like to conclude today's class. See you in the next class. Thank you.